Let's review just a little bit here. And by the way, welcome to Calculus Conundrums for the derivatives. Feel free to subscribe. If you have a constant raised to a constant, you know how to find the derivative of that, because a constant raised to a constant is just another constant, and so the derivative would be 0. If you have a variable or a function raised to a constant, then you know you just use your power rule. So in this case, the derivative of x to the fifth would be 5 times x to the fourth. But if you have a constant raised to a variable, like we have here, then you actually have to bring in logs. And so you remember that when we take the derivative of this, we would get 5 to the x times the natural log of 5. So now the question is, what happens if I have a function of x raised to a function of x? Well, I can't use the power rule, because to use the power rule, the exponent has to be a constant. I can't use the exponential rule here, because to use the exponential rule, the base has to be a constant. So what do I do if I have something like x to the x or something like 1 plus x to the x? How do I deal with that? Well, there is a way to do it, but it involves taking logs and then implicit differentiation. So how do we deal with that? First thing we're going to do is we're going to take the natural log of both sides. So take the natural log of y and the natural log of 1 plus x to the x. Then you can use your log properties. Remember, there's a log property that says if you have the log of something to a power, you can write that as the power times the log. So I can write the natural log of 1 plus x to the x as x times the natural log of 1 plus x. Now I can just implicitly differentiate. So let's differentiate the natural log of y, take the derivative of that with respect to x, and that's going to be 1 over y times y prime. And then take the derivative of x times the natural log of 1 plus x, and that's going to require the product rule. And so remember, in the product rule, you take the first function, which is x, so I take that, and then multiply it by the derivative of the second function. So the derivative of natural log of 1 plus x would be 1 over 1 plus x. Now, since this is just 1 plus x, the general power rule doesn't kick in, because the derivative of 1 plus x is just 1. Now, had this been 1 plus x squared, then I would have had to multiply by the derivative of that, so I would have had a 2x here. But it's pretty simple. It's just 1 plus x. And then the second half of your product rule, you take the second function, which is natural log of 1 plus x, and then you multiply it by the derivative of the first function, and the derivative of x is just 1, so you just get natural log of 1 plus x. Okay, so now we have 1 over y times y prime equals this sum here of these two terms, and we can just put the x on top here if we want to. All right, now, so to get y prime by itself, just multiply both sides by y. So there, if you multiply both sides by y there, you'll get that. And then if you multiply here this all by y, let me just kind of squeeze it right there, you'll get what I've got below, which is y times x over 1 plus x times natural log of 1 plus x. So at this point, we have this for our answer. And then I like to tell students in class, boy, wouldn't it be nice if we knew what y was? Wouldn't that be nice? Well, if you remember, in the beginning, we do know what y is. Y is this, 1 plus x raised to the x. So now we can go ahead and replace y with 1 plus x to the x power, and we get our final answer. Y prime would simply be 1 plus x to the x power times the quantity x over 1 plus x plus the natural log of 1 plus x. And that, my friends, completes the conundrums over derivatives. So the next, when I get a chance, I'll start working with my calculus conundrums involving integrals, which is the inverse of finding derivatives.